Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at the Humble LED. And this video is prompted by a comment on a previous video regarding, I think it was latches and counting, and I mentioned using a resistor to limit the current through an LED. And the questioner was asking, well, how can the resistor limit current? Now, it's like many things in electronics, it's something I'd not really thought about. It's just something I've sort of known about for a long time and done. And I guess it doesn't limit the current. What it does is it divides up the voltage across the resistor and the LED, and in doing that achieves the current limiting. But I thought it might be interesting to actually get an LED and a resistor and take some measurements and see what we come up with. So let's start with looking at the circuit and what the LED manufacturers have to say about their devices. An incredibly simple circuit today then. Simply a LED in series with a resistor to limit the current from a 5-volt supply. I'm going to take current measurements, obviously in series there, and I'm also going to measure the voltage across the LED. Although initially I'm going to take just a few measurements across the resistor, because what I want to do is rearrange Ohm's law in terms of resistance and make sure that the current and voltage readings I'm actually getting do agree something like with the resistance. So that's just a bit of an accuracy check. It's an accuracy check of the resistor, but it's also of the measurement accuracy of the instruments I'm using, I guess. Looking at the data sheet, I'm using a yellow LED. Now this is a Rapid Electronics data sheet I managed to dig up off the internet, and the LED is a cheap Chinese LED, so I've no idea if it's exactly the same in terms of parameters, but for the purposes of these checks today it'll do. Maximum DC forward current there, 30 milliamps, although below it's interesting, it says peak forward current 150 milliamps, and there's a note 1, and note 1 says a 1/10th duty cycle, and it's 0.1 millisecond pulse width. So it'll stand 150 milliamps for 100 microseconds as long as it's a 10th duty cycle. So there we go. I'm not going to try that out today either. So a couple of graphs from the data sheet. That's forward voltage and forward current, so that's what we'll look at today, and those are the two things I can measure reasonably well. The other thing that I can't really measure is luminous intensity versus forward current, so I'm not going to try to do that, but I'll just include that graph for completeness. Okay, that's enough theory for right now. Let's hop onto the bench and look what the setup is like. Okay, here's the arrangement as described in the circuit diagram on the bench. We've got the LED, which is glowing, but you probably can't see it terribly well. It's quite a bright morning here, and that's the LED. The resistor is actually this box, which is an adjustable set of resistances, or a decade box, whatever you want to call it. I've got the Kaiweets ST600 measuring the voltage across the LED, and I've got the Kaiweets KM601 measuring the total current flowing through the circuit, and I've got a supply voltage of around 5 volts. So currently I've got about 2,900, well actually 2,990, so let's put that to 0. 2,900 ohms is the resistance. The LED is glowing, and you get the measurements here, about 0.76 milliamps and 1.88 volts across the LED. Now I'm going to drop straight down to 1,000 ohms, and there isn't a great deal of change in brightness. The current's gone up there by a little bit, but not masses. Now I've got that on 900 because it's very easy with this decade box. When I turn the thousands dial to 0 to give the diode the full 5 volts, LED the full 5 volts, and I'm trying to avoid doing that for obvious reasons. So we'll turn that to 0 because we've still got 900 dialed in here, and there is an appreciable change in brightness and also in current and voltage. Appreciate you probably can't see this very well. Won't grumble too much about British sunshine we don't get that much, but this morning we seem to have lots of it. So if I now start to step down, that's 800 ohms. You can see voltage is changing, current is rising. 700, 600, 500, and there's about 300 ohms. LED hopefully is visible in the camera now. I'm looking on the monitor, and yeah, I think it probably is just about visible as glowing. But we're up at nearly 4 milliamps and 1.97 volts across it. So if I go down to 200 ohms, current is increasing, not too much change in the voltage, and I'm now going to dial 90 ohms into there, so we're now on 190 ohms, and I'm going to proceed cautiously down, reducing that now. The brightness is coming up here, and we're now approaching 5 milliamps. So it's 140 ohms. We just got about 5 milliamps, something like that, and almost 2 volts across the diode. So if I continue going up there, we're now at 120 ohms, 110, and that's 100 ohms. So again, LED hopefully is a little bit brighter. I'm now going to change that to 9 before I go to 0 on here. So we're at 90 ohms here, and if we continue up, you can see now there's some larger changes in current as we come down. There's 60 ohms, 50 ohms, so it's gone up now nearly to 2 volts across the diode. And I'm gonna stop at 40, and I appreciate that there's a bewildering arrangement of numbers here, and you're probably thinking, what's this telling me, Bill? Well, so am I. Now, rather than bore the pants off you, what I've done is taken a whole series of measurements. So we'll have a look at those tables now and see what we can deduce from those measurements, but it's a simple experiment. Okay, the results then. Initially these are just the check results of the voltage measurement across the resistor. I just took 4 of them, and then I did the maths there. So voltage over current should give us the resistance, and the R box is simply the resistance that was on the decade box that I was using. Just 4 measurements. The voltage and the current measurements are taken directly off the meters, and the 4th column is the calculated resistance. And the good news is that pretty close, really. So that tells me 2 things. One is obviously the error in the R calc column is a mixture of the error in measurements and also the error in resistance in the substitution box. That won't be exactly correct, but I think for the purposes of my home electronics lab, that's pretty damn good, so I'm not going to grumble too much about that. Right, on to the real results, and finally the bit that you're interested in, or the bit that I'm interested in, is what was going on in terms of the LED. And I took quite a few measurements here, whether in that table, and if you're a whiz with numbers, you've already spotted all the trends. I'm not a whiz with numbers, so let's using the power of Excel, let's get some graphs and view that data in a way that hopefully makes a bit more sense. First of all then, voltage and current, with volts along the bottom and current along the up the side there. And if you compare that to the graph from the data sheet I showed you earlier, it's certainly similar in shape. To bear in mind it's obviously two completely different scales, but generally that's sort of agreeing with what goes on. Just bear in mind this is a Chinese LED, and the data sheet was for wherever Rapid Electronics got their LEDs from, and that data sheet was 2003, so we're talking 20 years ago. But the general shape, yes, exactly as you might expect. And I thought the other one that was quite interesting is to calculate what the effective resistance of the LED is, and compare that to the current. So current across the bottom, and we've got the calculated resistance up the side there, and you can see that as the forward current increases, the resistance changes, and it's well, arguably exponential. And it's probably fairly easy to see as we approach 50 milliamps, the effective resistance of the LED is 50 ohms, and I guess the resistance is changing because the light output of the LED is increasing fairly rapidly. Remember, the luminous intensity graph I showed you earlier was also a curve. And my understanding of LEDs is that when electrons hop across into holes on the semiconductor material, that causes a photon to be emitted, and clearly as we increase the number of photons, then the resistance must drop. So I think it's fairly easy. I didn't go beyond 50 milliamps. It was only a very cheap LED, but I thought it deserved to live, so I didn't kill it. Certainly below 50 milliamps you can see the current would continue to increase, certainly to the point where the LED wouldn't survive very long. Okay, well, simple circuit, some interesting results. I'm pleased that my results did actually agree with the data sheet. It's always a bonus when reality agrees with theory, and I am a pretty practical person really, so it's been good to see that. And clearly the choice of resistor you have when you're choosing to operate an LED is going to impact on brightness and also the life of the component. So hopefully that's made some sense and been useful to watch. I learned quite a bit along the way, and interestingly, whilst doing that and looking up how LEDs worked and this electroluminescence, I discovered that LEDs certainly in theory have been around a very long time, and the first practical LEDs apparently are just coming up on 60 years old. They were infrared. Certainly as a teenager in the 70s, I remember LEDs being exclusively red and pretty much exclusively in hobby electronic circuits used to indicate that the power was on or off or something like that. And it wasn't until a bit later that they started being used in multiple different ways. And of course they're everywhere now. So the good old LED, where would we be without it? Hope you've enjoyed the video. Those of you who've been deciding to get yourself a meter from Kaiweets and been using the code, thank you very much. Not only do you get a discount, you've also helped the channel. Really appreciate that. There's some links down below. Thanks very much for watching. Please click thumbs up and please subscribe. Costs you nothing to do either of those, but really helps the channel, and look forward to seeing you on the next video.